As Simon said, my name's Matthew Setter. I'll do a little bit more of an intro in a second. But the thing that I always like to do right at the start is because when I moved to the UK about 14 years ago, I had some lovely European friends who said, "You're really nice, Matt. We like you, but your accent's really broad. Our first language isn't English. I'm wondering if you could just soften your accent down." And I also spoke a bit too quickly then too. So if tonight I do, for some random reason, drop into a really strong Australian accent, a bit Crocodile Dundee, a bit Chris Hemsworth, or I start speaking too quickly, just let me know at some point, because I do sometimes get a little bit too enthusiastic, a bit carried away, and start speaking quicker and quicker, though I will try not to. Otherwise, if there are microphone problems, if I'm a bit too quiet, if I need to sort of do a little bit radio PHP Cambridge, like lean in closer, just speak louder, let me know, and I'll do that. Let's see, can I see the chat at the same time? Just do it in German. Okay, I could try that. Apparently I have a very cute German accent. I don't quite know what that means. But anyway, with that aside, let's actually begin. And I just want to say a very big thank you to Simon for having me this evening to give what is at least definitely currently my favorite talk, one that I've enjoyed giving and improving, and I hope that this version will be the best one that I've given so far. Now, there we go. Without wanting to distract too much from the main topic of the talk, if you don't know who I am, I'm Matthew Setter. You might know me better on Twitter and around the internets generally as SetterMJD, as I've been known by that handle for quite some time. More recently, I go by the term Web Dev with Matt, which is just where I'm sort of talking about, just as the name implies, web dev related things and interests and concepts. I've been writing code since about 1996. I think that would put me, when I got into it, PHP 3.2 on Red Hat 6.0. I did do like a little bit of Mac Basic as a kid, but I kind of really kicked off around about 96. Most of it being web-based, a few other things along the way, and I even wrote Visual Basic for applications connecting to Microsoft Access once, and I hope to never do that again. Anyway, little friendly banter aside, I've been using Docker since about 2015. After, I think it was around then that it stopped being like the absolute cool thing, and now it's more common. And generally, increasingly, I swear less at it, enjoy it more. And so for that and many other reasons that I'll explain here and there through the talk, I put this talk together based off of a book that I've written to hopefully help others enjoy it like I do, and containers more generally. So, one last thing before we kind of dive on in. If I have a good voice, if you can still hear me, if you like the talk tonight, if you'd like to get in touch, you can find me on most of the socials, LinkedIn, Twitter, and Instagram even. You can find me, I'm WebDev with Matt. You can find me at webdevwithmatt.com or email me, matthew@webdevwithmatt.com. So, what will you learn, or what do I hope to be able to impart to you this evening? While I can't guarantee what you'll learn, what I hope you'll take away from this talk are the following things, or should I say, this broadly, being how to deploy PHP apps using Docker Compose. Now, I guess that's a bit of a, okay, I figured that based on the topic of the talk, or the title of the talk. More specifically, I hope that I'll be able to show you how to build a Docker-based local development environment, along with how to test that and to deploy that locally, how to build a production deployment setup from, well, from, loose-ish way of speaking, from that development version, or kind of using that as a bit of a jumping off point might be a bit more accurate. How to build and tag self-contained Docker images, which are required when you're not working on your local machine. How to push those images to a remote Docker image registry, because you'll need them, or the Docker daemon will need them to deploy. As with the development version, how to test that production deployment before you make it, to make sure as much as possible that it's going to work and you've ironed out any bugs, any kinks that could get in the way. And finally, naturally, how to deploy to production. Now, I use the term production a lot because I think generally it's perhaps maybe the most meaningful kind of remote environment term, like development production, but kind of sub in for production any other remote environment that's not your local development machine, whether that's testing, staging, or whatever the nomenclature is that you're using. Now, as well as saying what I hope to impart, or what I want this talk to be, I want to say also, as you can see here, what this talk isn't. My aim in doing that is to, all being well, set expectations correctly. That way, at the end, if I did or didn't meet those expectations, you can call me out on it. If I just inadvertently missed something, for whatever reason, let me know. But hopefully, you know what you're going to get, and I set that correctly. So this talk isn't, as the slide says, a deep dive into Docker Compose or Docker, because within about an hour and probably at most hour 15, there's only so much I can cover. So I want to kind of really focus in on the core of how to, of the 6 rough steps that I've sort of set through before. However, there will be links, well, some sort of jumping off points throughout that you can sort of dive deeper into specific areas. So, the crux of the process is all made possible by Docker's architecture. Quoting the official documentation here, which you can see, Docker uses a client-server architecture. A Docker client talks to a Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and the daemon, as they do by default, can run on the same system, or you can connect a Docker client to a remote Docker daemon somewhere else. The Docker client and the Docker daemon communicate using a REST API over Unix sockets or a network interface. Given that, you can use Docker Compose to deploy to your local machine or a remote host, or in a workflow tool such as GitHub Actions to deploy your application to any given environment. No extra commands such as Docker Swarm or Kubernetes are required. Now, I'll say, to be fair, I'll sort of qualify that, but for the last time this evening. Later on, at the end, if you want to pick me up on certain things, please let me know. I'm not going to sort of overqualify and drag the talk out to get to that qualification. Sure, there are more advanced ways to deploy applications with Docker Compose than I'll step through this evening, and different applications have different needs, requirements, and so forth. But depending on the requirements of your app, the approach that I'll step through this evening may be all that you need, or may be a solid starting point, which I hope it will be. The main thing to keep in mind is which Docker daemon your Docker client is connecting to. So, why deploy with Docker Compose, especially when there are so many other deployment options that you could choose from? Well, I'll speak for myself and say that in my experience, after learning enough about Docker and Docker Compose, I'll sort of use those two a little interchangeably. I've found Docker to be a simpler, somewhat more homogeneous way of deploying than I'd been used to in the past using tools such as Rocketeer, Capistrano, and rsync over SSH. No negative reflection on any of those tools. I've found that by using some standardized files and a small set of commands, I can deploy an application almost as easily to a remote environment such as production as I can on my local development machine. What's more, when done well, so can any other developer on the project. And when I mean when done well is, when that Docker setup is put together properly, when it's well maintained, then other developers on the project can usually get up and running far, far quicker than with a number of other setups. I admit what I'm going to talk about this evening is independent of any continuous deployment tools, such as Circle CI and GitHub Actions, and that when using them, the process isn't quite so simple, but conceptually, deployments can be that straightforward. So, what are you going to need to follow along with this process? Gladly, not that much. Firstly, you need a broad familiarity or understanding with Docker, Docker Compose, specifically for terms such as image, container, and service. If you're using Linux, then you need Docker Engine. If you're on Mac OS or Windows, Docker Desktop. Well, I say Docker Desktop for Mac OS and Windows, but that has gotten a little bit blurry with the somewhat recent licensing change of Docker Desktop. But I'll stick with that for now because the personal or free plan is still pretty broad in what it allows. And the other reason being, despite the not much love necessarily, or not all the time, between macOS and Docker Desktop, if you're used to a more GUI-based environment, it can make your life a little bit easier. But if you prefer, you can use Docker Engine on all three platforms. The next thing is Docker Compose. Naturally, it does come, or version 1 does come, when you install Docker Desktop, and I believe also Docker Engine. I say that with a little bit of hesitancy about Docker Engine, but I've recommended here Docker Compose version 2, because while you can use version 1, in a semi-recent set of deployments, I found version 2 to be able to deploy significantly faster, as from debugging, it doesn't open as many SSH connections as version 1 does. Oh, fly in the room. What's more, because of that, you're less likely to hit firewall rate limits, which further exacerbate the deployment time. There is a little bit of feature difference between version 1 and version 2, but from a simplistic comparison, version 2 is loads better. Plus, it's also kind of more like a native command, but I'll come back to that at the end. Then you need access to a Docker image registry, such as Docker Hub, DigitalOcean's container registry, or the free open source Docker registry. And finally, you need a deployment server, naturally running Docker, and then Docker Compose. Now, like any good tutorial, technical article, technical docs, and talk, you need a demo application so that it kind of is more meaningful than just talking through a series of steps. So I want to show you the amazing application I'll be using for tonight's talk. And here it is. But seriously, it's a small one which is built using PHP's Mezio framework. And in all its glory, as you can see here, it lists the main cast of Hawaii 5.0, the 2010 to 2020 reboot, including the actors' profile pictures, names, and character names. In all seriousness, it's really not that sophisticated an app, rather a simple one that reads records from a MariaDB database and renders them, along with some static image files. It doesn't make use of logging, queuing, or caching services. I deliberately decided to keep the requirements relatively modest, just so that they didn't distract from the talk's primary purpose of deploying with Docker Compose. That said, I'm open to increasing it if you feel that by having a more sophisticated application, which would need a more sophisticated Docker Compose setup, that it could help convey the points better. Now, why Hawaii? Why Hawaii 5.0? Besides the fact I absolutely love the TV show. My wife and I were married on Oahu. Not necessarily near where you can see here in this photo, but if you haven't been there, it is a magical place. It's so stunningly beautiful. I hope this photo does it some justice. It's just magical, so I thought, I'll theme the demo application with something that means a lot to me so I can really get behind it. Now, digging deeper, the app itself will need 3 Docker services for it to function. A PHP runtime, as it's using PHP, a web server to serve the static content, and a database server to provide the dynamic information. No particular reason for MariaDB. If you have another database that PHP supports, you could easily swap that in. Now, this composition follows the Docker ethos of one process or service per container. I'm not meaning to allude toward microservices or the microservices versus monolithic debates that can go on, just to kind of point out or sort of work through a structure that is perhaps easier to reason with, easier to step through in a talk context, and one that's sort of easier, hopefully, to set up, to work through, to debug, to maintain. Now, the first thing we need to do, like most things with code, is to create the directory and file structure. I use commonly a somewhat simplistic file and directory structure, which you can see on the right hand side of the slide here. And that's located in the root directory of a given PHP project, or made available to it in a directory named Docker. Because I kind of figure that makes sense, and I can readily look at the name and know exactly what that's for. And also it doesn't clash with the major PHP frameworks such as Laravel, Symfony, Mezio, and so forth. I don't have a special reason for that name or this structure, really, other than noticing it was just what other people seem to use, and it worked for me, so I stuck with it and gradually worked with it over time. Now, the top level directory is then subdivided down into a series of subdirectories named after the respective services within the configuration. Then, within each of those service directories is a Docker file containing the instructions for building the underlying image for that service, and we'll see these throughout the course of the talk this evening. Then, alongside the Docker files are any supporting files for that particular image. For what it's worth, I used to take a slightly different approach, and that was to have a separate Docker file per service, per environment, such as for development, staging, and production. But after quite a bit of experimentation and feedback and recommendation, I've trimmed it down to this. I feel that this is a simpler setup. You can kind of do more with less, and it's much easier to take advantage of multi-stage builds, which I'll step through a bit later. Now, then, there is the base Docker Compose file, which will contain the configuration that is applicable to every environment or all of the defaults. And along with that, there is a Docker Compose file for each specific environment. Now these ones contain the environment specific additional settings or overrides to the existing ones. Now, let's start working through those Docker files. Starting off with the PHP services Docker file, it's somewhat long, but and because of that, I've split it up over a series of slides just so that it's more readable and the font size was legible as well. It starts off, as you can see highlighted here, with the from instruction, which specifies the base image for this stage of the build. Specifically, it uses the official Docker Hub PHP image using PHP 8.11 FPM, and then that is then based on the Alpine Linux distribution. Now, if you note at the end of the from string, you'll see as base. Well, this enables multi-stage builds. Now, if you're not familiar with the term, quoting the official docs, with multi-stage builds, you use multiple from statements in a Docker file. Now, each from instruction can use a different base stage than the one before it, or you could, as this example does, use the same one throughout. Because of this, you have quite a bit of flexibility and power, such as being able to selectively copy artifacts from one stage to another, leaving behind anything that you don't need, so that subsequent stages and really the final image is as small as it practically can be. While multi-stage builds can add complexity to the build process, when done well, they can both simplify it and, to reiterate, reduce the final image's size. Now, moving on. The next part, or the next step, is to call or to run the Docker PHP ext install script that comes with the official Docker Hub PHP images to install the PDO MySQL extension, so that logically PHP can interact with the database. One thing about this script is that while it's great and it's an awesome time saver, I don't know if suffers from is the right term, but it won't install dependencies for an extension. So if they're not available, such as the PDO PostgreSQL extension, then the command will fail because it will attempt to build the extension, won't have the dependencies, and the script will crash out. But I'll get on to a little possible better option in just a moment. Now, at this point here, the Docker file uses a bash if statement to install and enable xdebug if the environment argument, or the env argument, is set to development. The reason for this, and I'm more than happy and keen if to get alternative and better suggestions, is that in the development, or when deploying to development, where was I? I lost my place. Sorry. This will be the last stage used in the Docker file. So at that point, the last thing I want it to do is install and enable xdebug. But in production, the Docker file will run from this stage right through to the last one that I will get to shortly. And in that context, I definitely don't want xdebug installed, even though it's improved in recent years. So I want to conditionally either install it and enable it, or skip over it. And I'll cover how to set that env argument in a little bit. Now, as I mentioned just before, the Docker PHP ext install is reasonably limited in what it can do. However, as you can see here, this is the Docker PHP extension installer. Now, I haven't had really the chance to use it thoroughly enough to fully recommend it or not, but some colleagues and friends who have recommend it very, very highly. The key differences between this and the previous script is that this will install a range of, I think, almost all of the, or quite a number of PHP extensions. And the chart here indicates which version it will install it for, and will also install the dependencies for that extension, so that if you want it, it will do everything for you. Just something to think about if you're not aware of it. Now, then comes the next stage. And as with the previous stage, it starts off with a from instruction using the same image as before, but names it composer. Now, the reason that I've named it composer is because I only want to build the composer far file in this stage and then copy it over into the next stage where I'll use it. To do that, the two run instructions will first start off by using the Alpine Linux package manager APK to install Git, and then use the instructions that I've lifted from the from Composer to install Composer. Then we come to the third stage, third of four, which I've named dependencies. Again, uses the same base image as before. Then sets the work dir, or uses the work dir instruction to set the path which subsequent instructions will run relative to, if they use relative paths, because I just want to make it that bit easier to run the next copy instruction so that it'll be shorter. And that one will copy over the application source files into the images inside /var/www/html. Now, the second copy instruction, because it's got the from equals composer after it, will copy composer from /user/bin in the composer stage into /user/bin in this stage. By doing that, nothing else from that composer stage will remain at this point. So all the dependencies that were needed will then be thrown away. And again, it helps to keep the final image as small as possible. Then composer install is run to install PHP's dependencies. Now, there's one last stage, and again has the same base image as the previous three, but this time is named final. It sets the work dir, or uses the work dir instruction to set the base path that we'll make use of in the copy instruction. And then here in the copy instruction, it copies over from /var/www/html in the previous stage, the dependency stage, all of the source files plus PHP's dependencies into the same directory in this stage. Now, before I move on, I just want to cover a few little time savers and perhaps bug avoiders, if that's the right term. Each of the stages, as I was stressing, in the Docker file have used the same base image. That's fine, but as I noticed in an earlier version of this talk, I think all of this, the three of the four stages were exactly the same, but one, I think I was using a different version of either PHP or the Alpine Linux version. And gladly that wasn't a problem, but as is often the case, configuration changes can be both a big problem and also be like sometimes a hard to debug issue as well. So instead of explicitly naming the base image in each stage, instead you could use some Dockerfile arguments, such as in this example. Here, the PHP and Alpine Linux version strings have been defined as arguments, which are then used in the from directive doing some string interpolation. That way, if one or more versions change, you only need to change the arguments, and each stage that uses them is changed automatically. Now, you could, instead of setting the arguments directly here, you could set them in a Docker Compose file, as I'll cover later. And this could be quite helpful if you have a different Docker Compose file for a multiple or series of different versions of PHP, for example. Now, in addition, you could use one stage as an alias, as stages don't need to contain any instructions. By doing that, as I have here, each subsequent stage can be based on that stage. And a nice little, well, at least to me it's a benefit, is that if you have, say, a shorter, more meaningful name, then it makes it that much easier to read and to maintain over the course of time. Now, one final thing worth mentioning before we move on is my focus on Alpine Linux. The reason I do that is that, hang on, I'll just do a quick answer for, is it Mesh or Manuel? The slides will be available after, I'll publish the slides after the talk, so they will absolutely be available. The reason for Alpine Linux is that using it, the resulting image is often much smaller than basing an image on other distributions such as Ubuntu or Debian. Mainly because the base Alpine Linux image or images can start as low as 5 meg in size. This can reduce your image hosting and your transfer costs, and it's more or less a Docker best practice in that keep things as small as possible. And I guess we could also say, therefore, that it's eco-friendly or eco-friendlier as well. Now, let's look at the database's Docker file. The reason for this Docker file is just to simplify creating the database schema and loading data into the database inside the image. That way, when the application is deployed, the database is ready to go. Now, as I'm sure we all know, there are a host of ways that you could do this, and in all likelihood would, such as using a professional database hosting service like DigitalOcean's databases service, ScaleGrid, or Heroku, perhaps in tandem with a migration tool such as Doctrine Migrations. But for sakes of simplicity tonight, I'm just going to do it this way. I'm not advocating this as, an approach that you definitely should take. Now, the image there was based on the MariaDB, the official Docker Hub MariaDB image, and the copy instruction that I've highlighted here copies a SQL file, which we'll look at a bit of in just a moment, into the Docker entry point initdb.d directory inside the image. The reason for this is that the MariaDB and also the MySQL images, or the official Docker Hub ones, when the image is created, if they find a file ending in .sql or .sh and a few other extensions in that directory, we'll run it. So it's kind of a simplified schema creator and data loader. Sorry. Now, here's a bit of the SQL. As you can see, it's quite small, and it just contains the instructions to create one of the tables in the schema, which has a first name, last name, and email address. And here is another part to it where it just inserts some of the name of the characters with a very fictitious email address, just something to try and make it quasi-real. Did I mention I am a huge Hawaii Five-0 fan? I mean, after all, the lead actor, who you can see in the middle here, was Australian. He's from Sydney, down in the south. I'm from the north, so I won't hold that against him. And I hope you hear this. It has amazing music. Anyway, I promise that's the last Hawaii reference. Now, with the Docker Compose file, the Docker files and their supporting files ready, let's now work through the Docker Compose files. Starting off with Docker Compose.yml, which will contain the base settings. The configuration starts by setting up a persistable file system volume, which is used by the database container. Now, this is important because while file systems in Docker containers are writable, they don't persist changes across container restarts. This is because when a container is started, it uses the specified image at the time that the image was created, which, naturally, doesn't have any new files nor any changes to any existing ones. That can be okay, but it's not great when you're working with databases or other storage mechanisms. Sorry, I've got a little fly because of my plant in here, and occasionally it really gets in the way. So that's why we're creating a persistable volume, where any new files and changes to existing files will be kept across container restarts. We next define an element called services. Now this element, which I've split up over a number of slides as it's far too long for one, lists the definitions of the three services or containers which will make up the application. It starts off with the Nginx container. Given that it's named Nginx, the container will have a matching host name of Nginx as well. Now note that here it doesn't contain an image option to specify a base image to use or a build option to tell it where to get its build instructions from. These will be specified in the environment specific Docker Compose files. Next, it sets the restart directive to unless stopped. By doing this, Docker will restart the container if it should crash or stop for some reason other than when it's intentionally shut down, such as by using Docker Compose down. Now, the restart directive supports 4 values. These are no, where not sure why that happened. Can't seem to get, there we go. Maybe the batteries in this pointer are running low. If you set it to no, Docker doesn't restart the container for any reason. If you set it to always, Docker will always restart the container if it stops. If it's manually stopped, it's restarted only when the Docker daemon restarts or the container itself is manually restarted. And then there's on failure, where Docker will restart the container if the exit code indicates an on error failure, and unless stopped, which we've just seen. Now next, the depends on option creates a dependency of sorts between the service and the PHP service. Here I've just included one, but you could include an array of any number of relevant services. And we'll see that PHP service shortly. In short, it means that the Nginx service won't start until the PHP service is started. Now, the last configuration for this container is to add a health check. These determine if a container is considered healthy, or said another way, need to be restarted. Health checks gladly can be whatever you want them to be. There are no hard and fast rules that it has to comply with or an interface that you have to code against. In the case of this particular application, Mezio applications based on the Mezio skeleton project come with a ping endpoint, which return a JSON response containing the current timestamp at the time of the request. So it's a nice, if simplistic, way of testing whether the application is working. Given that, the health check makes up to 3 curl requests to that endpoint every 60 seconds, allowing for a 3-second timeout. If 3 attempts to the endpoint fail, then the container will be considered unhealthy. Now, the configuration for the PHP container is similar-ish to that of the Nginx container. I just want to stress that there are quite a number of other options you could put in, but I've tried to give kind of a little bit of a mixture without going over the top, to sort of make it meaningful at the same time. Now, you can see that it names the service PHP as, almost exactly to how the previous service was named Nginx. Consequently, the container will have a host name of PHP as well. It then sets the container or service to restart unless we stop it as before, and then uses the expose option to expose port 9000, but without publishing or binding it to the host machine, which makes it accessible from the Nginx and other services within the application. Now finally, for the database service. As with the other containers, it's been given a name and set to always restart unless stopped. This time though, we're using the build directive to tell it to use the Docker file located in the Docker database directory, which we stepped through before for its build instructions. Finally, it maps port 3306 in the container to the same port on the host machine, so that GUI tools such as DataGrip, maybe Eclipse, Navicat, and so forth, or the database tool inside PHP Storm can be used to administer it, and you could also use something like MySQL's command line client. So that way during development you can hack around if you want to do that or need to do that, check records in the database, and so forth. Now let's look at the Docker Compose file for the development version, called dockercompose.dev.yml. As I mentioned earlier, it contains additional directives relative to this environment or overrides. First, it uses the image option to tell it the base image to use, specifically the latest version or latest tag of the official Docker Hub Nginx image. Then it uses the ports option to map port 80 on the container to port 8080 on the host machine. No particular reason for this other than it's just the standard port that I use in development. Then the custom Nginx configuration file, which we'll see next, is copied into the image in place of the default version. After that, the current directory on the host machine is mounted inside the container at /var/www//html. Now, this lets us develop locally on our host machine, yet have the code be accessible to the Nginx container. This has the effect of sharing your local directory with the container, I guess rather like Vagrant shared folders. It makes local development, I think, pretty efficient, or at least I've found it to. And when you make a change in your development environment, whether in a text editor or an IDE, the changes are almost instantaneously available or synced to the container as well. So there's no need to manually copy files or sync files between your dev environment and the running container. Now, this is at least a good snippet of the Nginx configuration file. It isn't all that special, and I've kind of gutted most of it to try and focus on some really relevant parts. But what it does is extend the default Nginx configuration that comes with the official Nginx Docker Hub image to send all requests to /public/index.php, and then pass off those requests to the PHP service on port 9000. Now, let's step through the PHP service. The build directive that you can see highlighted, specifically through the context and Dockerfile subdirectives, tells it to use the Docker file located in docker/php, which we stepped through before, and it'll use that for its build instructions. By adding the target subdirective, we're telling it in this context to use the stage named base, effectively skipping all of the stages that come after it. Additionally, in the arg subdirective, we set the env argument to development so that it knows when running that stage to execute the condition which installs and enables xdebug. Now, Then, as with the Nginx service, it maps the local directory on our development machine to /var/www/html in the service. And finally, let's have a quick look at the changes for the database service. First, it sets the environment option, or uses the environment option, and here it passes environment variables to the container. Specifically, it sets 3. These are the database's name, the user's username, and password. You can find an official list of the ones that the image supports in the image's official docs, and I hope, because it's a demo app, you won't sort of hate me for having a username of user and a password of password. I guess it could have been worse. I could have set the password to 12345, but seriously. Then it uses the volumes directive, where it makes any changes in /var/live/mysql, where MariaDB stores its data files, makes them permanent, because they'll be written to the database directory inside the data directory in the project's root on the local machine. Now that we've finished the Docker Compose configuration, it's time to make a deploy using Docker Compose. Now, to do that, all we have to do at this point, as in the example here, is call Docker Compose up. And to that, we'd pass in, or we'd pass the file option twice. First, specifying the base or defaults file, and then secondly, specifying the file that contains the environment overrides and extensions as I have here. Then what it also does is pass in the build option, or specify the build option, just to make sure that the images are built at the same time. Now, from what I've gathered from the official documentation and forums, this seems to be the recommended way, at least the official Docker recommended way, when you're working with multiple environments. However, there are other ways, or there is a slightly different way, which I'll step through, because the net result is you can have a notably shorter command to work with. Now that works because if you don't specify a configuration file to Docker Compose, it will go looking for docker-compose.yml. And there, if it exists, it can just take that for all the instructions it needs. However, it will also look for, if it's available, a file called docker-compose.override.yml. So in effect, you can make use of these two default files to have a set of defaults and an override. However, I found it to be like a little bit of a catch when you're working with multiple environments. It works great for one, but for multiple, it's like, well, how do you specify like a series of environments, not just one? So the approach that I'm experimenting with at the moment is, and I'll skip through to the slide that shows it, is here, as we have so far, is have your base defaults as we have in Docker Compose.yml. Then for your for each environment, create an environment specific override and extension file, as you can see in these examples here. Then, though it doesn't work on Windows, but in a deployment environment, if you're not deploying on Windows, it would work. Create a symlink through your CI/CD tool from your particular environment specific file to Docker Compose override.yml. The net result, if I pop back a few slides to here, is that then you can have a command that's as short as it can be. Now I'll pop back forward again. Anyway, regardless of the approach that you take, after the command runs, and here's an example of what you'd see that on the first 4 to 5 lines, that the network and each of the containers, based on the instructions that we've supplied, would then be built and started. And then after that, from the line that says attaching to database 1, etc., all of the logs for each of those containers would be printed out. The reason why I do that locally first is that I'm not I've never mastered the art, if it actually exists, of getting something right the first time. So I do this so that I can see if there's something that I've missed in a configuration by it being printed out in the log files, such as there was a required configuration that I didn't supply, if there was something already bound to the port that I want one of the containers to bind to, if there was a missing configuration file, and so forth. And this makes it very easy and very quick to see that information. One thing to note, though, is that if this is the first time that you're working with the particular base images, that naturally they won't be in the local Docker cache. So Docker Compose will have to pull those down and sync them in its local cache first before it can go through the get to some building the containers or building the images on top of those images. So if you want to save yourself a bit of time, you can use the docker pull command, as in these examples here, to pre-cache or pre-pull those down and cache them locally. Now, if you're working with something like Podman or Kubernetes, the image names that I've been using and will continue to use won't work, because Docker prefixes or prepends docker.io/library onto them. I guess is just a bit of a time saver in the assumption that you're working with Docker Hub. Podman and Kubernetes don't do that. So you'll need to prefix, if you're using Docker Hub images, docker.io/library onto the image names. Just a little something worth noting. Now, getting back to the output and debugging and so forth. As I said, I start use the previous approach just so I can see everything and see if something's gone wrong. If something has, then I just press Control C, fix it up, and start again. If the logs then don't show anything, they show things like the database service, the database is ready to receive connections, PHP is fine, Nginx is fine, and so forth. Then I'd stop it, and as you can see here, pass the D flag, or alternatively, the longer detach option. Did I say flag? I meant option. And when this is passed, after the containers start, which I think was on like line 5, instead of attaching, it'll go into detach mode, where the containers are run in the background, but the logs aren't printed to the terminal anymore. But now that they're running, and we'll assume everything's fine, it's always handy to do just a little bit more checking, just to make sure. Now, to do that, you can use a combination of 2 commands, those being docker compose ps and docker compose logs. So the docker compose ps command is pretty analogous to Linux's ps command, which displays process status information. If we run it, as you can see here, it'll show a list of the containers in the configuration, including their name, state, and ports. This way, we can quickly see if all of the containers are up and running, or if there's a problem with one or more of them. If you wanted to get a list or get the details of just one or a few, then as you can see here, after PS, I've passed in the name of one of the containers or services. And that effectively just filters down or filters the logs to only the logs for those specified services. Now, let's assume that docker compose ps showed that the database container had exited, so we want to learn why. To do that, we'd view the logs for that container, as I have here, using the docker compose logs command. By passing the name of the service after logs, as I did with PS, then it'll filter the logs down to just that service. So again, if you wanted to filter the logs by a series of services, just add their names space separated after the logs command. Secondly, by passing in the follow option, then what it'll do is we'll continuously print the logs to the terminal until you tell it to stop. Kind of like the tail option, or the tail command and its follow option. Now at this point, we'll assume that everything's running beautifully. So because of our configuration, if we opened our browser of choice to localhost or our IP address, and then add port 8080, we would see the application running amazingly, just like this amazing application, which is totally not amazing. Did I mention I love Hawaii and Hawaii 5.0? Oh, and, it's not here. I have had down by my desk for the longest amount of time the entire box set of Hawaii 5.0. But I don't have it, so I can't prove my absolute love of that show. I don't watch that much TV. I only watch about 2 TV shows. Anyway. Oh, that's right. I said I wouldn't bring it up again. Okay. I'm sprung. I think there's one more reference to like one more screenshot, but that's it. Okay, but seriously. Double strike. Now that we've made the deployment to the local machine, which really effectively is the core of what is going on, let's have a quick recap of what was covered. We've created a directory structure to store the Docker files that we need, along with any supporting files. What's more, it's nicely structured around the services. This way, if we want to add more services later, internal surfer error, nice. Then if we want to add more services later, then we have a pretty decent structure to build upon, or to sort of help guide us. We've created Docker files for each of the 3 services that compose our application, which we'll later use to create the images which Docker Compose used to launch the containers with. I still love that internal surfer error. We based each image on an existing base image so that we only had to do as little as possible, but gaining a lot of functionality right out of the proverbial box. We then created a 3-service Docker Compose configuration with a combination of a broad base Docker Compose file, which was complemented by an environment-specific one. The configuration used the Docker files which we created, one that supported health checks so that we know if a service was ready or not, which synced the source files to the running container, yet which let us work locally without having to copy over files when we'd change them. We set environment variables, configured the services to auto restart if they crashed, and made the database service available to local database tools. We learned how to start or deploy the application locally using a single command, and we learned how to do basic status checking and debugging to see if something went wrong and to help us deal with it if something did go wrong. Now let's move on and start rapidly bringing the talk to a conclusion by seeing how to get ready to make a production deployment, or basically just a deployment to any machine other than your local development machine. So the first thing that we're going to do is create a Docker file for the Nginx service. Now, it wasn't necessary up until now, as up until this point, the Nginx service in the development environment used the official Docker Hub Nginx image because it didn't really need any special changes. But for production, that won't work. Now, I'll just quickly check that question. I believe that might be answered perhaps in this slide, or something analogous to it. If not, let's come around to this at the end. Now, the Docker file, again, uses the Docker Hub or the official Doghub Nginx image, and but this time based on the Alpine distribution. The work dir instruction sets the work directory or the base path within the image where subsequent instructions will operate relative to, if relative paths are used. So if you use absolute paths, it's completely overridden, or ignored, I should say. Next, two copy instructions are used to copy the custom Nginx configuration file, which we saw previously, into the image inside /etc/nginx/conf.d, and the contents of the current working directory, so all the app source, configuration, and related files, into the image inside /var/www/html. It's so much easier in German just saying www instead of www. Then, using Alpine's package manager, it installs the required binaries that the image will need, then runs npm install to install the front-end dependencies. Just while we're on this, I think I tried to use the official npm or node image like as a separate image, so I didn't actually add more to this image than I needed to, but I couldn't get it working, so that's why I'm kind of using it explicitly here. And then with everything in place, it finishes up by running npx and npx and Tailwind CSS to build the application style sheet from the base configuration, instead of generating a sizable development version for use in production. Now, if you're not familiar with npx or Tailwind CSS, if you hate front-end stuff, CSS and all that, that's fine. The aim here is to, again, just sort of create or sort of simulate what you might likely do, as opposed to sort of pick on specific tools. The end result of doing this, though, is that the generated style sheet will only contain, because of the configuration, the required CSS properties that the view templates use, and it'll be minified. That way, the file in production will be as small as possible and be generated only when required, so that it doesn't have to be stored under version control. Now, with that done, we need to create the production or Docker Compose file for the production environment. Now, you can see, similar to the local development configuration, it'll have, I should say you will see in the next slide, it'll have the same services with largely the same configuration, but there are a few key differences to pay attention to. The Nginx service will use an image which we'll create in the next section, and instead of mapping port 80 in the container to port 8080 on the host, it'll map it to port 80 instead, that being the default HTTP port. Now, depending on your security settings and the configuration of your servers, you'd also have to add the user that was running this to the relevant group, such as Docker, staff, ADM, or admin, so that it had sufficient permissions to bind on port 8080. Now, similar to the Nginx service, the PHP service uses the image that we'll create in a moment. We could, and likely would at this point, add in extra options here for production, such as security settings, or specifying the number of replicas and the way that those replicas would be used, such as maybe round robin. But for sakes of simplicity, I haven't done that. Now, for the database service, similar to the other two services, it'll use an image, which again we'll cover shortly. And this time it sets the same three environment settings as before, but since in this example here we're not explicitly setting the values, they'll be retrieved from the environment where Docker Compose is run. Now, as I'm sure we all know, there are a number of ways to set environment variables, But for sakes of simplicity tonight, I'll use one way to do it is to use the export command. Again, as this is a test app, I'm sure username and password are probably fine. However, we could approach this a different way. As you can see here in this example, what happens here is that Docker Compose would look in, unless specified, unless you overrode it, it would look in the default environment configuration file being .env for key value pairs set to the ones that we have here, those being db name, db user, and db password. And so they need be no more complex than this. If you're interested, however, if the file is in a different path, if it's just named differently for whatever reason, you can use the env-file option to Docker Compose to override the name of that file. So we have all the configuration that we need. Now it's time to build and push those Docker images to a Docker image registry, whether on your local network or on a remote service, so that they're available at deployment time. To do that, as hopefully the commands are following a kind of hopefully intuitive pattern, we use the docker build command as in these three examples here. Now, note the options supplied. Firstly, file, or we could use the shorter F option, provides the name and path of the Docker file containing the instructions for that image. Now, the reason why we're doing this is Docker would look for a file named Docker file in the local directory. But since we're building a series of different images and those Docker files are in directories outside of the current directory, we need to specify the path to it. Secondly, we're specifying the path to the image's context, or where all the commands will run relative to, that being the dot or period at the end of each of the three commands. And finally, we specify the tag option. You could also use the shorter T option to tag the image. Now this is, at least to me, is really cool, because note that the tag here starts with webdev with Matt, which is my Docker Hub username, or it could be my username on whatever service I'm using. By doing this, when the images are pushed, which we'll do shortly, the information doesn't have to be specified again, as it will be automatically retrieved from the image. Now, we could also specify a Docker registry URL, or basically the URL to the service we're using, if we weren't using Docker Hub, such as using DigitalOcean's container registry. And again, that information as well would be picked up from the image. I just want to note, I'm not paid to plug Docker Hub, nor DigitalOcean. They're just the services I've used the most, so I have the most, they're the ones that I have the most experience with. So it was kind of simplest for me to use them, but kind of sub in any other service that you're more familiar with. And no, I'm not getting any financial kickbacks to plug them. Now, what we're also doing here in this highlighted section is giving the image a name and a tag. Now these, we can call whatever we want within normal naming restrictions, but so long as they're unique to our account and also that they make sense. Because it's great that you can name it whatever you want, but if it doesn't mean anything, then that's going to get old really quick. So here I've just kind of given it, kind of said what the image is for in a quasi-intuitive way and called it latest. You could also follow semantic versioning to kind of provide yourself with a quasi rollback functionality. Now, once the images have been built, we can confirm that they're ready by using Docker images command. And this will just look in the local Docker image cache to check if they're there. Here, in this simplistic example, we see the repository and the tag names. and that they were created a little while ago, how big they are, and their unique ID. If you had put a registry URL in, I believe that would be printed out as well. I've kind of trimmed back the information in the slide just so that it's kind of easier to read. Now, another thing worth noting is that if you're working on multiple projects, which you likely are, if you've been working with Docker or Podman and stuff for a while, if you like to experiment like me, then you'll likely have quite a number of images in there. So you will get a just scrolling output, which is hard when you just want to quickly find what you need. So my suggestion, though I say it with a caveat, is to use the filter command as I have in this not so intuitive example. Really what it's looking for is something, actually, it doesn't sync up with this example here. I should have started it with like web dev with Matt and then ended with latest. It's just looking, it's a kind of simplistic pattern match on the repository and tag in this case. One thing to be aware of, unless the docs have changed since I last looked at them, is while the filter option is really wickedly powerful once you get your head around it, the documentation for it leaves a little bit to be desired. But once you get the hang of it, it's great for just getting rid of anything in the output that you don't need. Now, with the images built and tagged, it's time to store them or push them to a Docker registry so that they're accessible no matter where the deployment is run from and no matter what runs it. For the purposes of this talk, as I said, I'm just using Docker Hub, but feel free to use whatever other service you prefer. The reason I stress that is that a number of people have said that they don't feel comfortable using an American cloud provider or a remote provider. They would prefer to have maybe sort of stuff more under their control, perhaps because of NDAs and so forth. So yeah, you can use the open source Docker, I think it's Docker registry or Docker image registry, and you can set that up yourself with public-private keys and so forth. But regardless, depending on the service, you use the Docker push command to push your images to it, as in this example here. Naturally, if you have to authenticate to it, first you use Docker login, passing your username and password, or you may have already provided an SSH key previously when setting up Docker on, setting up your account on that remote service. Now, I can't speak for services other than DigitalOcean's container registry, but it, I think when you have the doctl or doctl command installed, when you call Docker login, it will automatically or transparently authenticate to DigitalOcean's container registry. I hope other services will work in a similar way. So you can just stick with like a Docker-esque set of commands and not have to do sort of too much extra work or remember too many extra things. But here we are, and we're about to make the deployment. Before we do that, though, just to stress testing, you can do it locally and all but guarantee that it will work remotely. To do that, as before, as we did in development, run docker compose up. This time, note the only difference is the second file or configuration file that we're passing, that being the one for the production environment and not the development environment. That being, winding right back to the start of the talk, is because the real only difference that you have to think of, okay, there are many, but one of the key ones is which daemon is the Docker client connecting to. While it's still the same one, it will kind of almost do exactly the same things as in a full remote deployment. Now, as before, when the terminal's output stops scrolling, we can then, because it was in detach mode, we can use docker compose ps again, using again the production file, to check if all the container states are listed as up. If so, we can be pretty sure that the deployment will work. if one of the containers status columns is listed as starting, that is likely due to the health check perhaps taking a little bit longer than it needs to. So if you give it a few seconds and check again, it should be up and running. Try that again. With the deployment or local test deployment a success, you can now use Docker Compose down because we don't need that running anymore. And at this point, we're ready to deploy to production. Almost. I keep saying almost. I promise we are rapidly coming to the end, and this is the last big thing. Before we can do that, we need to tell the local Docker client which Docker daemon to use so that when we run the commands, it will deploy there instead of locally. Now, to connect to it, to do that, we do one of three things. We set the docker_host environment variable before running the Docker commands, use the capital H or host options when running the Docker commands, or use or create and enable a Docker context, and then run the commands as we normally would. So here you can see an example of setting the Docker host environment variable when running a command and before running a command, or in a bash one-liner, as well as the capital H and host options when running the command. And you can see that it specifies in these cases that it's going to connect over SSH. It's going to use the username of webdev_with_Matt, or that user on the remote machine, and it's just a placeholder for your production host name or IP address. Now, if you want, and there are kind of pros and cons as to which one to use. From what I picked up from the Docker blog, the official recommendation is a context, which I'll step through in just a second. But I have found, at least so far, when using GitHub Actions, the environment variable or the host and H options can be just a bit easier. Creating a context can be smooth and kind of reduce the errors that can crop up. Now, a context or a Docker client can have multiple context or remote daemons that it connects to, and the context contains the information that it needs to connect and communicate with those respective daemons. When working with them, you generally only have to do two things. Those being, first create it in the first place, and then set it to be used as the default for all future commands. Then you just run your commands as you normally would. So an example of doing that is on the first line, Docker context create, and then pass in the name of that context, something that is meaningful for you. Remote's probably not the best, but I could have called that production or whatever made most sense. Then, as with the previous examples, specify how to connect. So SSH or TCP. I think TCP, at least by reading some forums, was considered a little flaky and SSH was better. Then the user on the remote host that will be running or be sort of you'll be acting as, and then your IP address or host name. Then after that, call Docker context use and pass in the name of the context you want to set as the default from here on in. If you were to run Docker context ls or list, as in this example, you'd see all of the available contexts. I've cut down the output just to make it easy to read. And here I've kind of only got two, but you feasibly could have quite a number, or your CI/CD box could. The only real difference is the asterisk next to the name in the name column, which just indicates this is the one that will be used for any commands run. Now at this point, let's assume that I've set it up as before, pointing to my remote box with all the relevant details. Now, if I run Docker Compose up as before with the detach flag, passing in the production override file, then the Docker client on my local machine will connect to the remote Docker daemon on my host, assuming I've passed in all the details, set up the firewall correctly, and make the deployment from there. So, local client connects to the remote box and does everything there. But for all intents and purposes, it looks the same in terms of your terminal output as though it were running locally. As always, did it work? Because we've set up a context and set it to be used, and we're passing in the production override file, then we can use PS as before to communicate with the remote Docker daemon and get the output back of the list of the process status information of the remote containers. If the output shows that everything's working, then if you load it in your browser, or if it's an API and you make a request to it, it should work. As always, you can also use the docker logs command if something's gone wrong to look at the log files to see what's happened and attempt to do some debugging. But at this point, we've done our production deployment or our remote deployment. So let's do a quick recap of what was covered. We covered how to build application images, how to store or push the images to an accessible Docker image registry. We learned how to tell the Docker client which Docker daemon to communicate with, whether that be just one remote one or multiple, how to build a deployment configuration for a remote environment, and how to deploy that application to the remote host. Now, while I appreciate there were a whole lot of things going on there, at this point, at least simplistically, perhaps not, you're now ready to deploy the application to any remote environment of your choosing while staying within a Docker ecosystem or a smallish set of Docker Compose commands. Now, we are very, very, very close to the end. I just want to mention one little thing, which is whilst we've made a successful deployment, and I don't want to detract from that, using this approach does require to be done manually, which can get old pretty quick. So you might want to use a build pipeline. And a better way to do that would be to integrate the approach into a CI tool or CD tool such as GitHub Actions, Circle CI, or TeamCity. Now, the reason that I haven't included those tonight is because, well, we're already at an hour and 20, and I didn't want to overly drag out the length of the talk, and really just wanted to focus on the concepts which you could apply to any of these or other tools later. And that's me at the end of the talk. Thank you very, very much for listening. If I haven't been too jokey, if you've enjoyed the topic of the talk tonight, this talk was based off a book that I have available called Deploy with Docker Compose, The Essentials, which you can find at deploywithdockercompose.com. It covers the topic that I've stepped through tonight in a lot more detail, mainly because there's a lot more time, I guess, when you're reading at your leisure to dive a lot deeper into detail. But I like to think it doesn't go overboard. It's packed with a set of tips, tricks, pointers, things I've learned along the way, feedback that other wonderful people have given me that I will be integrating or am integrating at the moment. If you're interested, you can download a copy for free from deploywithdockercompose.com, just in return for your email address. And thank you very, very much for having me this evening. Thank you for your patience, especially at 1 hour and 22 minutes.